then one last quick thing, just a definition before we leave so you have it for your quiz. And that is, let's talk about partitions. So partitions are a group of sets that partition another set. And a partition just kind of means you break it up nice and even where there's no overlap. So I'll say B1 through Bn sets are a partition for A if and only if B1 union B2 union all the way out to Bn, the union of all of them equals A, and Bi intersect Bj is empty, so they're disjoint for all I and j in 1 to n. So all I'm saying here is that all of these sets are disjoint, or for all I not equal to j in 1 to n. Because obviously, like B1 and B1 aren't disjoint in the same set. I'm saying B1 and B2 are disjoint, B1 and B3 are disjoint, B2 and B3 are disjoint, and they're disjoint pairwise. Pairing two together, they're disjoint. That's what a partition is. It's partition, so it's something that breaks up a set, but they're disjoint. And we really like that in math because overlaps make things confusing, and if we go on them, they're really nice. So for example, 0, 1, negative 1, 0, and I'll say 1, 15, partition the set negative 1 to 15. The reason being, if we look at negative 1 to 15, and we have 0 and 1 in here, let's say this is red. So this goes from negative 1 to 0, including the ends. This goes from negative, I'm sorry, 0, 1 goes from 0 to 1, including the ends. Negative 1, 0 does not include the ends, so we don't have an overlap at 0. And then 1, 15 does not include the ends, so we don't have an overlap at 1. But notice, all these sets we put together, we get this set negative 1, 15, but they don't overlap. And we like that a lot. Another example would be the set of primes and the set of composites and the set of 1 partition n. The reason being that every natural number is either prime, composite, or 1, but none of these share elements. Anyway, though, that is partitions. And that is the last thing we need to cover in sets. Sorry for going over, but I wanted to get done today, so we'll talk about functions next time. And yes, so there's just a bunch of, sets are loaded, man. I mean, we have sets, we have subsets, we have set operations, we have set identities, we have ways to prove sets are equal, we have proper subsets versus regular subsets, we have disjoint sets, we have ordered pairs, we have partitions, we have a gamut of things we can do with sets, and it's kind of nice to do the foundation of math. But anyway, any questions on any of this? Told you it'd be dark. Dang, Richmond. It's probably so light in Blacksburg right now. All right. Well, then I'm going to keep this recording because I'm going to go over some of the optional examples I'm going to put up for you guys just because, like I said, there's so much material. I can't cover it all in an hour, but I want you guys to have it if you would like it. So I'm going to do that right now. You guys can stay or leave, do whatever you want. I mean, you can always do that for your country, but you can extra stay or leave now. And I'm just going to get to it.
Thank you.
Cool. Thank you.
You're welcome.